Hey guys, AP here, and today we are going to be making another tutorial in our Lightweight Java Game Library series. And I know it's been a while, it's been a couple months, but hopefully, I say hopefully a lot, but it hasn't really changed much. Anyways, let's just get on to the tutorial. I'll make videos when I can, and when it seems fit to. So right now we're going to be working on our third-person camera, because last tutorial we worked on our first-person camera, and if you don't remember how that was, here it is. It's looking pretty good. We can go inside it, because why not? And so yeah. So the third person it is like a set camera, like on a sphere around it, and the camera can move such where you can zoom in and out. I can't really show that with the first person, but it can zoom in and out, and then you can rotate it to always face the object. So no matter what, it faces the object in any orientation. If it's below it, it's like this. If it's like this, it's always going to face it. And so we are going to implement the math behind that. And so we're going to do that in our camera class, because that's where all the update functions are going to be. And so yes, so we already have our first-person camera update function, but we're going to add another one for third person. So we could say public void update, and to distinguish this update function from this one, we're actually going to have an argument in here that says which object we want the camera to always look at. And as you can see, no more error, because now the first person camera. So if we can go in here and actually put in our object, which is our cube, we can actually see that the camera now is just going to stare directly at it, and we can't control it. As you can see, I'm clicking on how I was controlling it before, and nothing's happening. So there we go. So now we can actually add the math. So what is the math exactly? Well, to actually explain this, I made a little diagram here on Paint, the best diagramming tool. We just get that all close up. Yeah, I can't really center it, but oh well. I mean, it can. Just have to do this and then move it, but I won't do that. So anyways, here's what we need to do. We first need to actually describe a few variables, and we're only going to describe two of them. We're going to describe the distance, which is how far the camera needs to be away from the object, and the circle right here is the object, and the angle at which the camera is, which is the horizontal angle. This angle right here is the vertical angle, like how high or low does the camera need to go, but we are actually not going to define a variable for that. We're just going to hard code that in, which I know isn't what we're supposed to do, but oh well. So first we need our two variables. We need the distance, and I'm just going to initialize that at 2, and we need our angle, which I'm going to initialize at 0. So with these So with these variables, we can actually tell what math we need to do for the camera. So in here, we need to know the distance and the vertical angle, which we can get from the camera's X rotation, as you can see. And so we need the horizontal distance, which is represented by H, and the vertical distance, which is represented by V. And this is the math that we need to do. Keep in mind that this is in radians, so all angles are in radians, so we actually have to convert those. And so let's get those variables in here. Started, we're actually going to define horizontal and vertical distance. So horizontal distance, and we actually need to put what data type it is. Horizontal distance is going to be equal to, and as the formula says, we need to do the distance, which is how far the camera is from the object, multiplied by the cosine, which is math.cosine, of the angle, the vertical angle, which we can get by just doing the x value of the rotation, and it has to be in radians, so math.2 radians, and then rotation.get x. So with that, we can, we probably have to cast this to float because math deals with doubles. This math class deals with doubles. Alright, so now that we have the horizontal distance, we can actually get the vertical distance by saying horizontal distance, or vertical distance, is equal to distance times sine. And actually we can keep the vertical distance in a variable just to make things a bit more simple. Horizontal distance is equal to 0. Vertical distance is also equal to 0. Let's just initialize that too. And just so you guys understand this, instead of saying rotation.getX, let's say vertical distance. And this is simplify things. Ooh. Local variable has not been initialized. Well, it has been up here. Oh, I said distance, and I have to say angle, horizontal angle, and vertical angle. Vertical angle. Boom, boom. So with this, we can actually get the H and the V. And the V, as said before, is going to be the Y offset. So we're done with vertical. We're done with the bottom one. But we actually need to get the X and Z offset using the horizontal. So if we're looking on top of the object, the camera is sort of like an angle, which is the actual angle, the horizontal angle in this instance. And we can use the same math sine and cosine functions to get the X and Z. Now I know this is a hard explanation to see, but like see, this is the side, so, and the camera is looking down and it's sort of up from the object. We can use the vertical angle to find the vertical and the horizontal, and then we can use the horizontal to figure out the X and Z, and this is the top, and so this is off to the right and a little bit forward a little bit. So that is how it works, and if you don't understand that, just use the functions and they should work. So now we need to find the X and Y offset. So we need to initialize more variables. So X offset is going to be equal to well, basically this, except instead of using the distance, we have to use the horizontal distance, and instead of using cosine, we have to use sine. So horizontal distance, and then we actually have to change vertical angle to horizontal angle, and for some reason it has to be negative. I don't know why, but it does. And so with this, we can actually do the same for the Z value, except, you know, it's cosine. It's usually the opposite. So with these variables defined, we can actually tell the new position of the camera. So let's set the position. So position.set to the previous position. So position.getX plus the X offset. And so let's copy this and do it for the other two. And then for the Z offset, you just say Z and Z. And then for the Y offset, you have to subtract, and you have to do Y, because subtracting, it makes sense. Actually, yeah. And it's actually not called Y offset, it's called vertical distance, because just to make variable naming the same. Now if we run this, you can see that nothing gets changed. The only difference is I get yeeted out of existence. Oh, it's because it's not. Oh, I'm a stupid head. It's the object's position. So object.getPosition. I'm stupid. Sorry for my stupidity. I have like notes here of what I need to do, and I looked over there, and it didn't say do that. All right, so there we go. Now, as you can see, you still can't control it because we haven't added input to it. So let's have input to it. So I want to control this using the mouse and not the keyboard, because that's how it usually is controlled. So let's do input.isButtonDown glfw.glfw mouse button, and then if I want to move it, I want to use the left one. So this is to change the rotation of the camera. And so if I want to do the right one, I want to change the distance. So the first thing I'm going to do is the distance, and I'm going to actually have a constraint so I don't flip the camera and make it all glitchy. So if the distance is greater than 0, if it's greater than 0, then I want to do distance plus equals, and then since I'm working with mouse movement, I actually have to use the new mouse and the old mouse up here. So I'm actually just going to copy and paste this right here and delete unnecessary code. So all U is unnecessary, and then move U after we do all these math things. So now that we have the distance between previous and new mouse positions, we can actually use that to change the distance. And we also should multiply by the mouse sensitivity. Because this is a whole number, and whole number in OpenGL is kind of big, so let's change that. As you can see, we do that up here too. So if it's less than 0 or equal to 0, then we need to say the distance is equal to 0.1. So you can tell, and then F. So it's not like going outward of the camera, and so this is actually going to restrict it to far away from the camera, or kind of inside, or far away from the object and inside the object, which is much better than glitching out. So then when we do the left one, we actually have to use both of them, because we both have to change the vertical and horizontal angle. So vertical angle is equal to, or is subtracted by, and since we're working with vertical angle, we have to use dy dy times mouse sensitivity. And so the horizontal angle is kind of the same thing, except it has to be added because of that vertical being flipped for some reason. Anyways, so then we have to use dx, because if we're messing with horizontal, we have to go left and right, which is the x-axis. So horizontal angle plus equals math sensitivity. So now that we have some input into this, let's check it out. Alright, so now that we're in here, we can click the right one, and we can go in and out, and it kind of seems a bit too fast for me, so I might slow that down. And then if we click this, as you can see, our camera is changing, but the rotation is not. It's because we haven't actually added the rotation in there. So now that we have this working, if we can go around it, look around it. It's not looking at the object just yet because I haven't added it, but it's doing the correct movement. Alright, so like I said, I might slow this down to like 1/4 of the speed to see if that's a bit less jarring. Yeah, that's a bit better. Alright, so now that we have some input, we also need to finally add the rotation of it. So after we set the position, we could say rotation dot set, and then we have the XYZ. Well, we're not going to change the Z, because the Z is like how the camera is rotated left and right, and that would kind of look weird for any camera. So we're not going to affect that. But we are going to change the X and Y rotation. So weirdly enough, the X value we have to change, or the X value we have to use to change it, is the vertical angle, and it's because vertical angle is looking up and down, and the x-axis, just imagine like you're holding a pin, and you're setting another pin in the middle of it. I'm doing this myself, but you can't see it. If you rotate the pin in the middle, as you can see, it's going around that horizontal pin, and that's the x-axis. So we just have to put the vertical angle in here, And then, of course, do our simple thing and invert it. And so finally, we need to put the horizontal angle in there. And put that in there. So with all this in, we can finally get some rotation. Okay, so I did it the wrong way. So the vertical angle, the horizontal angle is supposed to be the one inverted, and the vertical angle is the one that's not. So, yeah. So there we go. We are rotating around this object. You really can't see it yet because it just kind of looks like I'm rotating the cube. But if we add more cubes in there, you'll see that we're actually rotating around the object. So that's what I'm going to do. I'm actually going to add more cubes in here. So the first thing we need to do is actually create a list of game objects. So game object array objects, and that's going to equal an array of, let's say, 500 objects. I think our engine can handle that, so 500. And then when we initialize it, we need to say, after we do all this, that for into I equals 0, I is less than objects dot length I plus plus, and then objects of I is equal to, and then we can just copy and paste this one. And we can actually say that the first object is equal to our created object, so we actually know which object we're gonna follow, and we're just gonna put this in the middle. And so now we kind of created 500 objects all in the center, so we actually need to change this to random positions. So math dot random times, let's say 50, and then minus 25, and that will give us a random number between negative 25 and 25. And so we need to do that for all of them, and we also probably need to cast a float. So float and probably have parentheses around this one. I know this is going to be a bit harder to do, but oh well. Boom, and then finally, if I can get this correct, boom. So now they're all floats. And I forgot a parentheses somewhere. Float, float, float. Oh, and then we have we need another parenthesis there. Alright, so now this generates 500 objects centered around it. And then finally, when we render, we need to say for, I'm just going to copy this one, for this, and then finally render object of it, objects of I. And don't do that. Boom. So now this renders all the object, and then it renders our single object, which is the one the camera's following, and there's still an error somewhere. Oh, game object. So now, after all this, we should have a nice camera that we can rotate around. And as you can see, it is actually rotating around the object, and the camera's rotating around the object, and it actually changes everything else. So as you can see, we have other objects in the scene, and it's not rotating around them, and it's not actually just rotating the single object, it's rotating the entire camera, which rotates the entire world. So as you can see, it looks pretty cool, I'm not gonna lie. It also shows that our engine can handle multiple objects in there, and so that's pretty cool. I don't think it's efficient, but it can do it. Like if we up the list to say 10,000, it's probably gonna cry, or my computer's gonna cry at least. Yeah, it's at a steady 10 frames. And so let me zoom out. Yeah, this is very laggy. And normally render engines can support this many. I mean, look at any game ever. It can support, what is this, 60,000 faces. It can support millions of faces. But our engine's kind of struggling to do that. It could be your computer, or it could be that the engine's bad, and it's the engine's bad. So I'll change that back to 500. So anyways, that is it for this tutorial. In the next tutorial, I'll actually get into loading in OBJ or just 3D models from a file, and instead of using this mundane method of defining a vertex and defining all of the other stuff. So anyways, that is it, and I will see you in the next tutorial. Bye!